High school is the last step. I'm not saying that I don't see anything after high school. I'm saying that after high school, my schoolmates and myself will enter the real world, the place where people don't care about how hard you tried, but how well you have prevailed. In the real world, it's not who thinks an idea that gets credit. It's the person who puts the idea to good use that's remembered. The Alpha Project at Skyview is all about this transition. Guided by Mike Murray, the students learn to grab a hold of their aspirations and ultimately begin a pursuit of perfection. The Alpha Project is quite possibly the world's only high school space program. They plan to be the first amateur rocket team to launch a probe into space. They are competing against a world of mature enthusiasts, several of which have large budgets, multi-million-dollar sponsors, and an extensive scientific background. Some of these amateurs are hardly amateur at all, yet this rocket club from Skyview plans to get there first. The Alpha Project bridges the gap between high school and the real world. In 1997, Mike Murray met with students such as Albert Bay, Jeff Guilfoyle, John Van Boxtel, Chris Furness, and others to begin the dream of space flight. Chris Trone, Brian Barnum, and Micah Erickson were only some of the students that followed in 1988. These students were interested in starting a long-term science project, and they were key players in the formation of the current program. Mike Murray introduced them to one of his personal passions, rocketry. The project began as an unofficial after-school activity, and there was no funding, but it worked. In the summer of 1998, they were able to launch a mission in the desert. Until then, Project Alpha operated on a minimal budget. But during the summer of 2000, they joined the Boy Scouts of America as an explorer post, and they got the support they needed. They did not launch a rocket into space that summer, but it was not a failure. The Alpha Project is a long-term project, meaning that most of its original members will not be a part of the team that finally launches a rocket into space. The 1998 team, composed of mostly sophomores, has since graduated and their positions have been replaced. A few of the old students do come back, and they are currently passing on what they have learned to their successors, who are going out to the desert this summer to do a follow-up attempt on achieving space. Every step of the design process is progressed by the students themselves. They were presented with the project and they have persisted ever since. Their first duty was to research how the professionals have done it. They found there were two options: to fire a rocket from ground with a powerful enough booster to fight Earth's gravitational pull the whole way up, or to build a balloon structure that would carry the rocket to the upper 1% of the Earth's atmosphere and launch from a gondola. The second method proved to be more feasible, so it was chosen. Brian Barnum took responsibility as balloon manager. To do this, he first had to know the background of his field. He did research on James Van Allen, the designer of the balloon and gondola launch method. Then he performed mathematical and physical experiments based on his newfound knowledge. And once he reached conclusions, he presented his findings to the team. They adjusted it until it worked for them as a group of high school students trying to launch a rocket into space with little experience and a minimal budget. Since then, their experience has caused the project to evolve even more. It was originally discussed that a GPS system would be fixed into the rocket, but that was eventually thrown out because it was too expensive and not necessary. A second system was chosen to replace it. It records displacement on a small computer located in the nose cone. Albert Bay designed the software that calculates the trajectory based on physics equations, previous testing data, and standard scientific constants. The exact launch procedure then had to be developed. The whole time during the design process, the students had to keep in mind all the variables that would cause problems during the rocket's flight. Project Alpha is completely different from any other high school science class because it bridges the gap between the educational world and the real world. Students are not restricted to reading out of textbooks or working on study problems. They're working in the scientific community, collaborating with real scientists, and making contributions. Project Alpha is for students who have become impatient with their education and want to do something more meaningful. They don't want to have to wait until they're in college or until they get into the Air Force. These students are ready to push themselves to gain experience by doing things. They understand that the world they live in cares more about what they have done and less about what they could have. Project Alpha offers students a chance to get hands-on experience, to work with their future. Students quickly learn about their field of interest, whether it is radio, rockets, weather balloons, or journalism. They learn what works and what doesn't.